Unit 4A, Lesson 1, Interpret the Structure of Expressions. In this lesson, we're going to talk about quadratic expressions, and specifically, we're going to work on factoring down quadratic expressions, which simply means we're going to break them down. The first thing we need to do is discuss what a quadratic expression is. In the past, we've talked about linear equations, linear expressions a lot, discussed exponential expressions. Now we're going to dive into quadratic expressions. It's simply an expression in x, and it can be written in standard form, ax squared plus bx plus c. A, b, and c are any real number, except that a cannot be equal to 0. Because if a was equal to 0, then we would not have this first expression, and we would be left with bx plus c, which is simply a linear expression. So a, b, and c represent any real number. A cannot be 0. Below are some examples of quadratic expressions. In the first one, we have 3x squared plus 4x minus 8. Our a value would be 3, the b value would be 4, and the c value would be negative 8. The one on the right, we have 7x squared. Our a value is 7. Our b and c values would just be 0 in this case. The bottom left, we have x squared minus 16. Our a value would be 1. Our b value would be 0, and our c value is negative 16. And then the last one, our a value is radical 7, b value 0, c value is positive 13. In all these examples, we must have an x squared term. We don't necessarily have to have a b or a c value, a bx or a c term, for it to be a quadratic expression. You just have to have that x squared term. For the rest of the lesson, we're going to work with factoring quadratic expressions, and specifically, we're going to be dealing with quadratic expressions that have a leading coefficient of 1, meaning the a value is 1. So in the first example, we have x squared plus 13x plus 36. We're trying to break this down into linear factors. Okay, that way it makes it easier later on for us to try to solve these types of equations. So the first thing I'm going to do is make a list of factors for our constant c, which is 36. Now that I have my list of factors for 36, I'm looking for the combination of factors such that when I add those two factors together, the sum is equal to my b value, which in this case is 13. So if I add 36 and 1, that would be 37. That doesn't get me 13. 18 plus 2 is 20. That's not 13. 12 and 3 would get me 15. Then I get to 9 and 4. If I add 9 plus 4, that gets me to 13. So that's the combination of factors I'm going to want to use. So now we're going to break this down. And since this is an x squared, I'm going to have an x and an x in front of both sets of my parentheses. Then I'm going to take my two factors, 9 and 4, and they're both positive. So I have x plus 9 and not x plus 9, x plus 4. So we find all of our factors of our constant c, list those factors. We're finding the combination that when we add those two factors together, we get the b value. Then we combine those two factors into our binomials. So we have x plus 9 times x plus 4. Now that we've gone through one example of how to factor quadratic expressions, there are 4 different cases for the quadratic expression based on the signs in front of b and c. And if we understand those values, then we can determine what the values of our factors must be. So for the first example, our b and c values were both positive. Actually, a, b, and c were all 3 positive. So I knew both of my factors had to be positive. In this second example, we have a is positive, b is negative, and c is positive. So if my middle term's negative and my constant is positive, I know both factors have to be negative. Because when I take those two factors, if I multiply two negatives together, I get a positive value for c. And if I add two negative values, well, I'm going to get a negative value for b. The third example, a is positive, b is positive, and c is negative. So in this case, the only way you can get a negative value when multiplying two values together is if one is positive and one is negative. So I know one of my factors is positive and one of them is negative. If my value of b is positive, I know the larger value of my two factors must be positive. Then the last example, a is positive, b is negative, and c is negative. So again, both factors, or one of the factors must be negative, one must be positive. But this time, since b is negative, that means the larger factor, the larger absolute value, must be a negative value. Okay? So this is just a quick way, if you understand these signs, that helps you determine the signs on your factors. Also, when dealing with quadratic expressions, make sure to rewrite them so that your a value is always positive. For the ones starting out that we're going to work with, a is always going to be positive. To end this lesson, we're just going to go through 3 examples of factoring quadratic expressions. We're going to look at the value of b and c to help us determine what factor combinations we should look for. So in this case, I know my middle term is negative, b is negative, and c is positive. So if b is negative and c is positive, that means both of my factors for 40 must be negative. Because if I take a negative times a negative, I'll get a positive 40. And if I add two negative values together, the result is going to be negative. So I need to make a list of factors for 40 where both factors are negative. So I make my list of factors for 40. I'm looking for the combination that when I add these two factors together, that sum is negative 14. So in this case, the combination that's going to work is negative 10 and negative 4. So I'm breaking this down into my two linear binomials. I have an x squared, so I know I'm going to have an x and an x. And now I put my two factors in, so I have x minus 10 and x minus 4. So we started with x squared minus 14x plus 40. We factored that down to get x minus 10 times x minus 4. In the next example, we have x squared plus x minus 30. So I look at my value of b, it's positive, and my value of c is negative. So I know one of my factors has to be negative, one of them has to be positive, and since my middle term is negative, I know the larger absolute value of those two factors must be positive. So I make my list of factors for negative 30 such that the larger of those two factors is positive. Now that I have my list of factors, I'm looking for the combination where the sum of those two factors is a positive 1. There's understood to be a 1 in front of x. The combination that works is 6 and negative 5. If I take 6 plus negative 5, I get a positive 1. So when we break this down into our two linear binomials, it's going to be x and x. And then I have a positive 6 and a negative 5. So x plus 6 times x minus 5, that is the factored form of x squared plus x minus 30. Now to the last example, we have x squared minus 3x minus 40. So I look at my value of c, it's negative. So I know one of my factors has to be positive and one of them has to be negative. Then I look at my b value, which is also negative. So when I know I'm looking at my two factors, the one that has the larger absolute value must be the negative factor. Now when I look at my list of possible factors, I'm looking for the combination of factors. When I take that sum, I get negative 3. The combination that works is negative 8 and positive 5. So I can factor this down into x minus 8 and x plus 5. This is the factored form from the original quadratic expression that was written in standard form.